I made a multi-tool using lots of 3D printed parts as well as some other hardware, which I will explain how it all works together. So these are some inserts, some blades and some pivots that I combine with 3D printed parts. These threaded inserts will go into the 3D print and then will produce an hexagon that we can use to add a screwdriver bits. So that goes into the plastic. I'll show how you put it in there. And one of the other tools we have is a type of file or a sanding stick if you wish. So I made just a flat plate and I'm gonna glue into it a piece of sandpaper. So basically it could be any sandpaper you want. Just gonna cut it to size. And that's the blade. So I'm gonna use some super glue to hold it. This is a way that people make sanding sticks. You can glue sandpaper to wood, and in this case we're gluing it to PLA, which is the 3D print polymer. I'm putting a clamp so the super glue has time to harden. Even though it starts to harden fast, it's better to give it some time to really get some strength. Meanwhile, I'm gonna put together the utility blade. So that's the 3D print, and I'm adding these little blades, which I will link in the description. And it goes into a groove in the holder, and then if we push it, there is a bit of a plastic spring that will hold it in place. If we line it up, then that cylinder goes into the hole in the blade, and now it's kind of locked. And to remove it, you need to kind of push it down. So the blade's ready. Here's the handle. I'm gonna assemble there, putting the blade through a pivot, and I'm also using some washers that are 3D printed too. Everything has to line up. I sped it up because it's a bit slow, all this alignment. And then you have it. I'm gonna show you how to add the insert. So basically the trick is to heat it up. In this case, I'm gonna heat it up with a candle and then put it in the plastic real quick. Another way to heat it up is using a soldering iron, like the ones that are used for electronics, and probably there be other ways too, like if you put in some sort of oven or such. It's probably more precise, but if you heat it up and then screw it real quick, that's enough to get it right. It took me a couple tries to get the technique. So that insert will hold a 4mm screwdriver bits, and then those are good for example, precision, and then some light duty kind of house home repairs such. So I was surprised that it is pretty strong. Here I'm using a Torx bit for a pivot. And if you add an adapter, you could have a 1/4" bits. So it's another way to add more functionality using an adapter. It's very small and also lightweight. The actual weight is like 15.2 grams. In ounces, that's 0.53, so it's about half an ounce. Very lightweight because it's mostly plastic. And the size is about less than 3 inches when closed. If we open it, it's about over 4 inches, and then you can see the width is approximately ½ inch depending on where you measure. So possible improvement is to add a holder so you can carry the bits at all times. Another thing to make it a little bit more secure, I am adding here an elastic that will keep these things closed, so this blade don't open when you're carrying it in your pocket. Maybe there's a better way to do that too. So I think this could be a basis for lots of more cooler designs. I'm gonna put links to the STLs and all the hardware. Thank you for watching.